Hello everyone. Today we reached our last part in chemistry for grade 8. Let's get started. Okay, so today's lesson is going to be about exploring combustion. What is combustion and what does it mean, or what are the things regarding it? Okay, for an example, when we burn a candle on a birthday cake, or we actually set fire, like by even doing some barbecue or anything else. So the whole burning process is actually a chemical reaction forming new products, and it's like the whole burning thing, it cannot be reversible. Why? Try to take a piece of paper and burn it. Can you take it back? No, you can't. So here the chemical reaction is actually irreversible. That means burning itself, it cannot be taken back. Once you burn thing, you get a new product. It's either gas or anything else, but in the same time it's like you cannot take the paper or whatever item or object you actually burned back. So when you burn wood or coal, new products are made. The reaction is also irreversible. That means you cannot get the wood or coal back. This means that the burning is actually a chemical reaction. Okay, but in order to start a fire, what do I need? I need a fuel to burn it, and I need the presence of oxygen. Otherwise, none of them will be like in a complete combustion or a burn. A fuel is any material that can be burned to release energy. For an example, there are wood, coal, and burning also needs oxygen. Without it, a fire would go out. That's why we always want, like we call it a triangle of burning. So it's like the item that you want to burn with the fuel and the presence of oxygen. The scientific name for burning is actually combustion. We can summarize what is needed for combustion using the fire triangle, which is oxygen, heat, and fuel. If any of the three components are missing, the combustion wouldn't be happening. You can use this information when you're trying actually to light a fire or put out a fire. For an example here, when we're lighting a barbecue, a match may be used as a source of heat to start the fire. The fuel is used in the barbecue is often charcoal. And as long as oxygen is available, the charcoal will then burn. When you need to put out the barbecue, you can either prevent oxygen from reaching the fire by covering it with a blanket, or remove the heat by throwing water over the fire, or not adding more charcoal. Understanding combustion and the use of fuels. We use combustion reactions every day, from cooking food or heating in our homes. Even the electricity which we use actually sometimes relies on combustion. Combustion here is an exothermic reaction. This means that the reaction here, what does it do? It releases energy. And this energy is usually transferred as heat and sometimes as light. It depends on what sort of thing I'm actually trying to get out of it. The combustion is very important for transportation. For an example, when we use them for trains, cars, trucks, and for fireworks is another example for combustion in action. Usually when we use electricity, you're relying on combustion. Like in power stations, fuel is burned and the heat given off is used to boil water. The steam produced, we use it to drive a turbine that actually generates electricity. This means that you're relying on combustion in the first place when you're turning your lights on, playing computer, or charging up some games console. Okay, in situations such as burning logs on fire, like for camp, it's easy to identify the fuel as wood. However, in other situations like using electric fire to heat a room, it's not actually obvious. Electricity is not a fuel, but it is sometimes generating using a fuel. If the electricity was generated in a coal-fired power station, then we actually use the fuel to heat the room was actually coal. Traditional steam engines also use coal as a fuel, and traditional cars use petroleum or diesel as a fuel. These both come from crude oil, or biofuels like ethanol can be used in some cars. This is an alcohol made from grains like barley. We already discussed this in our biology section when we said that we use plants to make out the ethanol, this alcohol, that we use it as a biofuel. And space rockets can be fueled by the liquid hydrogen. Exploring the effects of burning. For combustion to take place, there needs to be oxygen. Without it, or without the enough amount of oxygen, it may be sort of like a problem. Why? Because when we have the exact amount of oxygen that we want in order to burn something or have the combustion process going on, this is what we call a complete burning or a complete combustion. But when we have a small amount of oxygen, we call it here incomplete combustion. And usually the product is in complete combustion is actually carbon dioxide, but meanwhile in the incomplete is actually carbon monoxide, which is a toxic gas. Many fuels like coal, oil, and gas contain the elements hydrogen and carbon. They are called hydrocarbons. Like hydrocarbon with oxygen gives me carbon dioxide and water. And this reaction, we call it complete combustion. This means that there is enough oxygen to react with all the fuel. And this is an example of oxidation. Oxidation is adding oxygen to the reaction. Carbon dioxide is known as a greenhouse gas. Any excess of this gas is not used by the plants, forms a blanket around the earth, and most scientists believe that burning fossil fuel is actually contributing with a greenhouse effect. The incomplete combustion, that means we don't have enough amount of oxygen available to react with all the fuel, so we have something called incomplete combustion takes place, and water is still produced, but carbon monoxide and carbon were produced instead of carbon dioxide. So a hydrocarbon here with oxygen, we get carbon monoxide with water, or carbon with water. Carbon monoxide is a poisonous gas, and the carbon formed this way is soot. Those that we find it in the chimney pots in the British or the European sort of houses, when they have there's localized fireplaces, they actually burn coal and everything, and you will find out that fine black powder that usually irritates their respiratory system and everything. It's called soot. So soot is a fine black powder that can irritate the lungs and airways, and incomplete combustion also releases less energy than a complete combustion. Last but not least, we've got the last section here and the last lesson in chemistry, which is understanding acid rain. Where does acid rain come from? For an example here, I'm burning coal, and when I burn coal, a lot of gases are released, and one of them is actually the sulfur compounds. The sulfur compounds here are toxic gases, and when they actually I wouldn't say escape, but more likely as they continue flowing through the air, they reach where the clouds are. Rain in its nature is slightly acidic. When I'm telling you slightly, that means it's acidic in a small amount. But when it meets these gases and they are soluble in water, so practically the rain here increases its acidity, leading to a fall of acid rain onto the environment. And when it does, it actually has a major effect on the human, on the plant, on the animals. Normal rain is slightly acidic with a pH of other polluting gases can reduce it to 4 or lower. This is acid rain, which can damage plants, animals, and even buildings, and it's a worldwide problem. Combustion pollutes the air with chemicals like carbon dioxide and sulfur dioxide and nitrogen oxide. The sulfur dioxide is formed when sulfur found in some fossil fuels like coal and oil, and it's been oxidized during the combustion. That means adding oxygen or reacting with oxygen. The nitrogen oxides here are formed when nitrogen from the air is oxidized during the combustion or the burning process. Both sulfur dioxide and nitrogen oxide are extremely soluble gases that rise up into the atmosphere and dissolve in water, forming sulfuric acid and nitric acid. These acids can then fall as acid rain. The rain clouds can travel huge distance, and so pollution in one part of the world may cause acid rain in another part of a country. The effects of acid rain. Acid rain can kill whole trees or even whole sections of forest. This is because acid rain can damage the leaf plants and means that photosynthesis cannot happen efficiently. Also, acid rain dissolves some useful nutrients from the soil and then washes them away before the plant has time to even absorb them, and also causes harmful chemicals like aluminium to be released into the soil, which are then absorbed by plant. And acid rain looks and feels like normal rain, but however, the chemicals that cause acid rain can be harmful to humans and can cause respiratory disease such as asthma and bronchitis, which is an inflammation in the bronchus. And acid rain can even damage the buildings and statues. This is because the acid reacts with the stone and wears it away. Finally, we can say we've finished the revision of chemistry. Looking forward for any questions, and good luck everyone.